Alright, with this one, I can see that my two functions, when I find my difference function, are not going to give me a polynomial. So there's not a lot of benefit in trying to sketch a function that I don't know what it might look like if it's tech-free. So the best port of, or the best plot then is to work with your two different functions separately, because I know that I can sketch 4 over x, that's a hyperbola, and I know I can sketch y equals x, that's just a straight line. Okay, so what I have is that I have, well, I've got f of x is 4 over x, I have, and that's my equation 1, and g of x is my equation 2. Now, in order to find my limits of integration, they have said to me from 1 to 3, but I have got no idea what's happening in between 1 and 3, and whether these graphs actually cross each other somewhere in the middle. So my first thing I need to do is to find out where these graphs intersect and figure out whether something happens between x equals 1 and x equals 3. So we're going to substitute 1 into 2 for our intersection. And so what we have is we have that x equals 4 over x. Remember, f of x is the same as saying y, and g of x is also the same as saying y. So both of them are y equals, and we put the two y's equal to each other. And what we have there is that x squared is equal to 4. So x must be equal to plus or minus 2. Now what that tells me is that I've got 2 points of intersection at x equals 2 and at x equals negative 2. Because we're not trying to find the area around about negative 2, I'm actually going to ignore that. Okay? So I'm going to say discard x equals negative 2 as not in the required area. And now I need to find my y value to find my actual intersection point. So when x equals 2, and I have a look and I see, well, there we go, I have y also equals 2. So my point of intersection is going to be at 2 and 2. All right. Now, that means that I've got a point over here where these two things intersect. Now I know that the line y equals x goes at a 45-degree angle, and that's what that line looks like. But what if I can't remember? Maybe I won't draw it so long, seeing as I have to write over there. What if I can't remember how to sketch a hyperbola? Well, never fear, draw yourself a table of values. Doesn't matter. Okay, so y equals 4 over x. Even if you don't remember it's a hyperbola, give yourself a bunch of values. Okay, so we've got x, we've got y. You might want to give yourself a few values before 0 and after 0, just to make sure that you know what this thing looks like. Okay, so I'm going to go from negative 3, negative 2, negative 1, 0, 1, 2, and 3. I'm not too interested in anything past there. Okay, so I've got negative 4 over 3, negative 2, negative 4. At 0, it's not defined. Then I have, when x equals 1, I have 4, 2, and 4 on 3. And what that does is it gives me a few points that I can just plot them in and get an idea of what things look like. I'm not going to plot the negative side, so I've got 1 and 4, 2 and 2. Oh, great. That makes sense. It goes straight through that point. And 3 and 1 and a third. All right. And that just gives me a feel for my hyperbola. All right. Next thing I'm going to do is I need to show what areas I'm interested in. And I'm going to put them in because we know we're going from 1 to 3. So let's draw ourselves a line there between our two functions at 1 and another one here at 3. And as you can see, the trapped area between the two functions falls over here. Now, it makes a whole lot of sense to also label your functions with your f of x and your g of x. Okay, so our hyperbola is f of x and our straight line is g of x. That's because depending on which function is above or below the other one, we are going to do a subtraction. Okay, so I want you to remember, give yourself a little star somewhere to remember, it's always going to be the top function minus the bottom function. If you don't remember to do it that way, you're going to mess up all your signs and you are not going to get the answer correct. So let's call this area 1, we'll call this area 2. So our total area is going to be area 1 plus area 2. Okay, but now area 1, have a look, f of x is above g of x. So that means I'm going to have f of x minus g of x. So I have the integral. Now, we're only going between 1 and 2 because that's where that area is. So it's from integral from 1 to 2 of f of x minus g of x dx. And then I want to add area 2. Now have a look in area 2. G of x is above f of x. So in area 2, I'm going from 2 to 3. And that's going to be g of x minus f of x dx. Okay. And so now what we're doing is we're going to say, okay, well that's fine. I can integrate between 1 and 2. And f of x was 4 over x, and g of x was x, so minus x dx, plus the integral from 2 to 3 of x minus 4 over x dx. Okay, and now we can actually do our integration. So remember, our integral of 1 over x is ln x, so it's going to be 4 ln x minus x squared on 2 between 1 and 2, plus, and then we have x squared on 2 minus 4 ln x, and that's between 2 and 3. And we can substitute in, so we get 4 ln 2 minus 4 on 2. What's your signs? Minus 4 ln 1 minus a half. And all of that gets added to 9 over 2 minus 4 ln 3 minus 4 over 2 minus 4 ln 2. And 4 ln 2 minus 2, let's just tidy that up a little bit. So 4 ln 2 minus 2, and ln 1 is always going to be 0, so that goes away. So then we have plus a half, and we're going to add that to, let's have a look, we've got 9 over 2 minus 4 over 2, that gives us 5 over 2. So 5 over 2 minus 4 ln 3 plus 4 ln 2. Okay, that's starting to come together nicely, because a half plus 5 on 2 add together, and that gives me 6 on 2, which is 3, and 3 minus 2 is 1. So I have 4 ln 2 minus 4 ln 3 plus 4 ln 2 plus 1. And I can use my log laws to just simplify that a little bit. If I take out my 4's, I can have 4 ln 2 minus ln 3 plus ln 2 plus 1, and that gives me 4 ln of 2 times 2 over 3 and that gives me 4 ln 4 on 3 plus 1. Okay, and this is tech free, so that would be your final answer. Square units.